Good morning. Or whatever it is, wherever you are. So we got some basic responses working of the style of the main Elm library, which I still want to evaluate if that is how we want to do it. Because that is storing essentially, well, I guess that's not closures, it's partially applied functions. I'm pretty sure they recommend against doing function state, but we're doing a lot of weird things here. So one possibility is we wrap that up in a program that sort of handles some of the HTTP stuff. And I might want to do that with something like an effect type. Well, it's actually not necessarily easy to find commands. So there's all the Lambda things. Which are probably our main source of commands. Now what I've done so far is I've had the sort of, we've got a single event type that is every message that can come back, that can come in from the system. But commands are individual functions in our Surface API. Would it make sense to somehow wrap that up so that we would have like decrypt list secret as a command that would be fully data, would be fully inspectable at some level? Maybe you'd still have a function wrapper around it. Well, we're expecting you to open up the events. Decrypt, we've got HTTP request, takes a structure. And then we've got response. Okay, so that is a result thing that does these specific. Well, maybe you'd still have response as a helper, and then more at the specific command level. And you just have encoders and decoders for that type. That would. So we'd have commands to Lambda. We'd have none. We'd have any other command that had to get passed through. But you do it at that level, or do you do it at this level? Because you've got like this the sub-program produces its own like effect type. Well, if this update is returning those effects, that has to be interpreted properly by the upper layer. So either you use the upper layer's effects type, or you have to provide a function to translate your effects into its effects. At some point you have to return its effect type. So that actually sounds like the Lambda system would have its effect type. We would produce that instead of commands, and there would be a function that translated its effect to commands. And then as you sort of put those translation layers in, you'll eventually be able to lift up the program. Or we could make a no-op Lambda program. And then that could gradually insert layers and change types. Say, do you actually change things? This ends up returning it right now. Does an update with all requests. With all requests. So we're doing error handling. I'm wondering if I could translate these into local application messages and not do any direct state translations here. That's effectively what anything calling update is doing. So it would just translate that into new event, and that would be the thing that it would do. We'd have to have a way to have an event that did error response. Update decrypted, that's effectively translating to a message. These are error response, HTTP response. Oh, this would be at the Lambda layer, actually. Let's update with this message. Yeah, so can I translate this thing in a way that it translates the Lambda event to an application event? Oh, wait, error response. Is error response state itself thing? With all requests, which requests are the pending requests that we're waiting to be properly executed. Those have a state which contains their session. And the things that are doing this are not tied to any particular pending request. Now this kind of goes back into the system where we sort of hang on to things all the time. And then as data comes in, we would match them up. All right, so a piece of this is we need to be able to get this to the point where everything is calling update, because at that point we can effectively replace this by translating to that event. But that means we need an application event that is some kind of error. Error response, error response. Okay, that's used down here. Also use an error response state. So that would kind of take care of that transitively. What would this look like? So this is new event. New event. We could translate new event to a result. Essentially, we'd be applying the decoder to it. Then our new event. Oh, we've got new event. Instead of being the new event state, would be a result with a decoder error. And it's either that, or we have to have a separate application event for errors that happen at that level. It's a gut token. Okay, that does have a response. Okay, so that's an HTTP response. And then that is all in decrypted, which is not HTTP. So we're translating that to a decrypted only in that state. Okay, so the with all requests thing. Command fold. Right, so we're just doing the command batch. With all requests is only used for error response state. It's also, well, step shows up outside sometimes, I think. Well, it mostly shows up in a pen state. Decrypted is application level. Okay, so it's currently all application level. So we do kind of want that to return the model command type. So do we add, let's see, there's an error. See, there's the direct error response. And there's a error response state for all of this stuff. I mean, I could just punt this to decrypted result, which is more or less a straight-up translation. Or it's punting all that up to the application level. Then that would translate to decrypted and, well, if that layer, that would make that a trivial translation. And the error handling would get done up there. Much like only dealing with positive cases. It would be kind of nice if we didn't have to have the handle thing in here. Well, that would kind of move up one level. Well, does it? Because that has to know the application types. Which is where subscriptions comes in the normal Elm architecture. Instead of case of, you say, I subscribe to new event with here's my handler. I subscribe to decrypted with here's my handler. Which is ultimately going to translate us into a message. So right now, we've just got Lambda event. And then you decode those things, and if you're not subscribed to a particular thing, then you just ignore it. So I guess that function can't move up because it's speaking in Lambda event terms. And you have to have something that translates those terms to the application level. It might be nice to, instead of having handle, the function that does a strict message translation. So your new event or error, and so we either have to pass up the error. Well, yeah, if we are able to take out the handle message, we have to we have to have like an error message. And that is error response state. Or maybe it's like a list of errors. So right now, with all requests, is implicitly clearing them. So that's a state change. So we would have to be able to handle both of those scenarios. Moving Lambda decrypted up. Oh. If you're dealing directly with that, where do we do the code response? So we map that to HTTP response. And that's just a straight up translation. If I did that in the presence of the layer model, you could just take the ID, look it up, and apply that. Well, no, because that gives you an application message, which has to get sent on to the application. So it has, is that doable as an intermediate layer? If it updates messages, and the callbacks can produce that type. Maybe that works. That's going to be its own little problem. So this does work as we're just updating an event. With all requests is not calling update, but it is performing a model change. So you're only producing it through update, so it could just be a message. You're returning the model as is, that's fine. You're doing update, so it could just be a message. You're doing update, so it could just be a message. So either we have an application event that is like fatal error, or we pass decrypted through and deal with it in the main loop. I guess it could, yeah, you could have like decryption error. But are we just kind of back to result type? I could apply an and then somewhere in the chain that checks the number of responses. Could that even be done at Lambda level? No, because we just get sent a decrypt request, which is just a list. The commands are fire and forget. Oh. Maybe I could have the upfront part do some translation of it. All right, so fail, fail. You're checking for how the events decode. And we have to have some way to do this. So that was not a result beforehand. That's going to essentially translate. So maybe the application new event has to be the result of the decode. Decryption could do a request map to create a result of the env from the 2 bits. All right, so that would take care of, that would be an and then. That would take care of those. Although we'd have to specify the error type. So I might have to do a map error to take whatever type this was. Well, that is decrypted is... Ah. So you're just a string. Where are we using that? Decryption error. So we could have an error type for that. But it's going to be decryption error message, so let's try to do string decoding and all the things we could possibly send. Yeah, just an error 2 string. So maybe the application would have some sort of decryption error. And then you could do like the underlying decryption error and wrong number of results. And at the application message level, you just have decryption OK env or some kind of error. And again, you can just put a string in there and it's not really a useful distinguish for the useful thing to distinguish for the app. So Lambda not decrypted. If we can take some of this result dot map error is fine. I'd actually want to be able to report. Well, I could, Since I'm just debug logging this. Result.map error. Oh. I didn't actually provide a second argument for you. So that would have just been a partially applied function. So we want to print it. We want to that takes care of the initial error. There's the crypt error. Result.end then, which only is in the success case. So this only applies to that, but it's still going to be some list. And we have to case something like you. We're just building up a result right now. I didn't actually need the env twice here. Oh, and in we're implicitly in an OK. Is there a thing that applies all the members of a list to the parts? Huh. Well, this is technically a structure, not a positional constructor. And then we have to deal with any other number of arguments. And we're already doing this to map it. Oh no, this isn't and then. We do have to specify that this thing is another result. So that would decrypt wrong number of results would kind of become the error. Which is not the same as some other decrypt error. And then somewhere we lost. Okay, so this maps the positive case. We have to fail out if we do that. And what do we do with this result? For now, we do have to do... We have to go ahead and translate this. Result. That's a middle argument, so I don't know of a... I mean, there's let block. Gabriel Moroni, thank you for the follow. I guess what I can do is I can start trying to prepare for that. And then do, like, message... In fact, that would be kind of a way to start translating this entire function. If you got everything in here to return message, you just tend to do this at the end. At that point, you could just kind of pivot it, though. And then my other decrypted has to deal with results, which are just strings. Maybe we could do a type here, but I'm not going to do any differentiated behavior. We're just reporting errors. So you're decrypted OK env. And you deal with this. Let's see, were all of these... Well, if decryption fails, it probably is a... Actually, both of these we're translating to this service-specific configuration. But we did do that. Most of those errors kind of got reported earlier. But maybe if I can do that there, I don't have to do it here. No, because we actually lose this error. In applying that, we could just not do this. And then you report the error and report this to the API response. I think we'll probably still have some misplaced types here. Did not properly lambda this. Oop. Unfortunately, I'm not actually decrypting in this environment. So it's a little bit hard to test this, but that was one step towards getting everything to just end in a message. That's kind of an especially big step. So that was actually my notes from last time. So update, direct response, or direct command, update. So in either we have to return new event, well, we could return it as a decode. We could sort of boot the entire thing up to application level and do the decoded place in the application message handler. We could do the decode here, pass up a result, and have to deal with that. That's kind of trivial, so we could have a case for it. It's either that we have like some sort of like unrecognized event error. If the application is determining what the events are, I mean, this thing is application level. So I guess the question is, do we make application new event take the result and do the decode here? It's not deciding what to do about it. Or do we just pass up the raw data and do the decode in place? It's kind of a one-line difference. This would take like data session and just do a new event data session. Actually, what are you were taking the completed state on success. I could make you a result. What do you need? Well, you need the error and the session to formulate the response. So we could have that produce the state, but the error of that result would need the session information to actually formulate a response. I could use the session to make a state and still have new event return a session. It seems like I should maybe just move the decode up. Which I was kind of trying to do that stuff in advance. And then this becomes just append state. Which is itself a model command response. Oh, append state takes the model. So you are not new event state, you are new event data session, just like the Lambda version. Well, it's doing less in the translator, but new event. Oh, we have to actually update this definition. Actually, you're both going to be values, aren't you? Yeah, I could move this up and then we'd have a, maybe have this kind of structure. But that would just be result session. It's not a very big win. Okay, that is actually somewhat testable. It doesn't touch the decryption stuff. Definitely makes the application a little bit less clean, but I guess we've still got, may still have some room to move things around once we've got this switched over. So now update event can become like receive event, lambda.event to command message. And then handle receive event, and then we don't even have oh, you took a error and only did this on the OK case. So that actually has to be, this has to handle the result. Well, we could map only the success case. But what do we do with the error? I mean, we really did nothing with it. So we lose the need for a handle message. Well, no, it's not command, it's message. Can't do command none. So we'd have to do something with the errors. Because that would only wrap us, mapping the result would only get us to a result of message error, or error message. Do I have to send something through if there's an error? Well, it's just an event decoder. Result.map error. Lambda decode error. Well, I could, instead of a result, I could map it to a special system error thing. But this is on the port subscription. It's going to result in some kind of message. I don't think there's any way to drop it. Even if I do a system message, we're still going to have to translate it into something on the other end. Although new event itself has a result in it. We don't know if it's actually a new event. I mean, this could have been a corrupt HTTP response, could have been anything. So map error maps it as an error. I guess to remove the, oh no, you do with default. To remove the resultiness of it. So if I have an error type here, I have to have an error type at the app. So it doesn't necessarily matter where you do that with default. It slightly simplifies your return types here. We're already mapping the error there, so it's getting at least logged. Maybe the application would want to be doing something better than debug log with it. So the information gets back either way. You have to deal with it either way. HTTP responses come back as results. And that was a request, so request succeeded, request failed. This is a really weird case where this should never happen, but we still have to deal with it. So we're decoding JSON, and decoding JSON can fail. That should be implementation detail, but I don't know of any way to just kind of drop it. All right, so conceptually, at the high level, it's kind of silly that we have these result types. And while it might technically be more useful to have the decode error there, it doesn't seem like it. Wrong tab. Doesn't seem terribly useful. Like we're really going to be able to do anything with it. And you kind of can't, well, technically it's a structured error. So we want to map error, now with default just, with default can't actually use anything with the error. So you can't like map a error value to a regular value. With default, returns a given default value. Transform the error, great. But I think we're actually going to have to do this. And at that point, doing the result mapping for this is meh. We want a let block for this? I mean, it's kind of a side effect thing anyway. We could actually print this in its native form. Actually, does this sort of turn into a pipeline? We just have to result in a success. And I guess for parity we do that. So now you can just be a plain old event. You can be a plain old event. And we were already halfway through this, so that is unfortunately not an isolated change. Yeah, it's just a Lambda event to message. It's like you're about to go away. But we've got something else. Oh. Cannot find update event method. Right, so you don't even have something to call. I could probably find a way to do that, but really, you should just be going away. Uh-oh. Oh, we haven't actually transformed this function. Details. Although that may have been HTTP match. Oh. The information that needs is stored in the model. All right, so parts of what we did were sort of okay. And really, I probably could have done a more targeted reset there. Decode dot error to string. And I then have to handle a system error case. Date event, thank you. I mean, if we add anything else, that's sort of like that weird case, where it's like it's kind of a unique thing. Well, new events kind of important too, but like as we add more events, they're gonna keep on going on down here. So in theory, it's already reported. All right, so that reduces the port type to non-result. And what I forgot to check for was other uses of model. So what we'd eventually want to happen here is that the Lambda system would be sort of using its own model. So it would get the event, it would translate it, it would call a sub-update function with its model. But in order to do the event translation, we have to have the callback. And no matter what, we're going to have to look up the mapping of things. So we can turn this into a function which produces messages instead of calling update. It's just got all HTTP match does the removal. So to actually work that out, I almost have to do the full program wrapper thing. I could translate Lambda HTTP response to my HTTP response and then deal with the state there. That would let you do at least that translation. But maybe that should be the local. Oh. If it was itself a full program, it could in fact short circuit certain things. Like that could effectively ignore decode results. So the other thing we've got is decrypted, which this is assuming the type of this stuff, which makes it so that it is application specific. All right, I need more water. I'll be back in a minute. See if that's the proper name of it, or if it's a medium. Oh, this changes everything. Oh my gosh. They weren't showing this in the trailers. We could just put our bases on the ceiling now.
Okay, we're getting a lot of iron. That's good to see. We're finding a whole bunch in this outside area. Okay, we could get down here and use this. Anybody have any recommendations for the neural vacillator?
Here comes the venerable Otto.
And we're back. So it could be that all of those turn into like subprogram updates. So the only things that send messages. Right, we still have this, which just calls that. All of these, well, this is all HTTP stuff, which gets handled by the callbacks, which are sort of related to the HTTP response. All of these are called from Lambda. So that just has to do with the translation layer. So nothing else really calls that. So that doesn't necessarily have to be the app message. So we could separate that update function and sort of a way to build towards it. We'll have to decide which one we want to be message. Okay, init is variable update. Actually, does update? Well, update necessarily receive. It probably calls functions that produce specific message types. Update event calls update, which produces specific message types. HTTP response. Okay, it can produce HTTP error, which is a specific message type. Decode response is variable. Spec JSON is variable. HTTP match. Yeah, so really it's the capital message. So something in there is specific. Probably the type of this dictionary that we're manipulating is the specific messages. Step. With all requests probably produces specific things. Append state. Do you actually produce anything? No. Command fold is actually very generic, and there could be some trickle effects from this. With all requests, your generic execute request. You might be dealing with specific structures. Remember, HTTP request manipulates the outstanding requests model, which has a specific type. If I changed my model to be variable in the message type, I might be able to generalize the command type as well. That's a Lambda response. It doesn't actually mention a message type. Error response state is similar. Which means you're probably similar. HTTP request would have to be variable in the expect type. And this is our one that's local for this application. To Lambda request. Lambda HTTP request is probably not type specific. Subscriptions is going to be type specific. So model is an outstanding request of a particular type. That's probably fine. So if we break this up, we have two message types, and then we have to get very specific about which is which. I guess we would do it like that. Because those are the only external events we get. So now we have this weird thing where this is like Lambda update. Or Lambda message. Which calls update event. But that calls back to update. So if we leave update as is, these types might have to match. So I might not be able to, you know what? I did some other cleanup changes here. So I think we're going to need some kind of like pass-through layer. Because our types aren't going to make sense here. We're going to update event. Update's going to call you. There's no handle. Or update event's going to call update. But having this return command message, I think, is where it's going to fall down. Because those probably have to be matched types. Subscriptions. Well, okay, we did. So that we can make that match, but that probably means our update. Init value, command last message. And it is in fact the update that is off. It is init untyped. Okay, yeah, it is effectively untyped. So you have to be a Lambda message. Which means we have to do we have to have some way to map those. Even though I don't think the system can ever generate these. I have to have a way to map the types in the response, because it could be commands of blah. And I guess, let's see, the HTTP commands. What, did we ever fix step? Well, we've got other problems right now. We can't. Can't sort out. So the trivial way to do this is we do that, and then we do message and every time we come back from one of these, we have to do command.map name duplication. Update event. Model command message. Oh, command map is on a function. Well, no, is it a command or is it a... Probably is. I probably do have to break it out and deal with it. Message is produced by a command. Okay, so that's the mapper. Yep, is the command itself. We had a thing. We had command fold. Command map. You know, you actually don't care about the model type, do you? Was model command.map function. Okay, that gets to compile. Right. Okay, so that was that debugging, which maybe could go now. Oh, yeah, we had the tags. You kind of got better feedback about what was going on. Now, is there a better way to do that? and have this app message that will never actually happen. This is sort of an internal detail. So the commands produce, so actually what we're thinking about doing is sort of translating the lower update, or the inner update, into kind of like effect type. In which case you wouldn't just be able to treat that as the return type anyway. If we can get rid of app message, then the event type of the top level kind of just is lambda.event. If it's singular, it doesn't need to be there. So it'll just be a no-op map. I mean, I guess if you did like time or something, you'd have to deal with other sources or other ports. Could be a different incoming event stream. That would make update event kind of essentially the handler, but you produce application messages. Well, if that produces effects, we interpret the effects, produce any real commands in terms of our own message. Okay, so this is compilable. It's not particularly useful at this stage, but I think we need to take a slightly different step to move this direction. Okay, your specific model type. Lambda update doesn't currently care about the model type. It will eventually have its own model. You call functions that care about it. I don't think you care about it yourself. Well, if you directly call functions that care about it, you care about it. HTTP match modifies it. Step. Looks into it. Append state looks into it. With all requests looks into it. Depends on remember HTTP request, which does modify it. Error response state is just convenience. Doesn't care about the model at all. And subscriptions, since we're not using the model, it could be whatever. I have any other notes? Tracking next action for the individual things. So we lost that thread a little bit. So we would define essentially the effect type of these updates. Which would be, well, so this would be an effect message if it's variable. So it would have to produce, well, no, I think the point of doing this is that we don't have to deal with that. So maybe we just leave out the command escape. And let the very top level deal with that. So our effects are essentially our Lambda things. So our effects are going to be decrypt. I think it's a list secret. An HTTP request? Is that going to be in app terms or Lambda terms? For the time being, it's going to be easier to do a lambda.http request and continue doing the translation up front. So at the moment, these are all Lambda things. So you could have like a Lambda effect type and have a singular function that did that. You might still be handy to have the functions in the Lambda module. Then again, they all end up doing Lambda command, so you could treat that as just encoders. And then go to Lambda command. Does perform care? Might have to type that, but then it'll sort of be implicitly typed from the update function. Oh, type alias. The message is also a constructor. So even though the types are separate, that's kind of unfortunate. Okay, that types in isolation. You know what? Oh, we're specifically applying command map of that. Yeah, map second. Because we're essentially translating the second part of it from a effect to a command. So I guess this could also be tuple.map second. Well, oh no, we can do so where does it go? F is a function. It's applied to it. Oh, maybe just command.map of F. No. Oh, because we're you have to pass that stuff to it. Okay. So that's command map. But we need a similar thing for this, which is just to perform. Effects model effect. Oh. All right, because we haven't actually updated any of these functions yet. So you are in effect, which gets a little bit hairy with all the types that go on here. I guess one way to streamline that would have been to figure out all the things that produce, like the lowest level things that produce those things, and sort of collect those. Or I could have defined effect as command message. Ah, now you see we do have one more case. Oh, and I might need batching too. That's actually a really good point. All right, so we just got that. It's working a little bit ahead. Tuple.map second. Command map, at message. Type alias effect. We can't inspect actual commands. We can't really do anything else with that. We can start replacing some of this and then looking for, and then we start looking for all the sort of downstream things. All right, is that correct, or did I replace? Okay. All right, model command. It might be hard to actually find everything without the type system just telling us. So update event. So there's the command none. You have to make that a function rather than a just no effect thing. I don't know if that's worth it. Just putting the function there is worth it just yet. So you're doing a Lambda decrypt. Oh yeah, all this meta stuff. Command.none. Command.batch. Did I just express that as, what are we folding? With all requests. That's still application level, not Lambda level. Oh, Lambda response. Missed that one. What is response? That needs all that stuff. Oh, I did a value somewhere. It's a little bit better description. I don't see how to do that with less. So all those things need to get translated. Okay, so error response, is that something we do from both? That's from update, 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 update. Okay. Error response state. Well, I guess one way to find that out is to start typing these. Okay. Right, because it doesn't matter, so we just wrap app message around and it's kind of all okay. But if you're doing a we eventually want this to be in effect. You are calling error response, so we eventually want you to be in effect. And send response to be in effect. Now, some of our command lowercase message things, since we generalized them, actually need to be speaking in effects. Yeah, so we've got like command fold, command map. This is our HTTP mapper. I think you'd be in effect. With all requests, main update, step is a helper for main update. So can we make you an effect? And you an effect. It's just a type alias, so it's not really doing anything. Well, it's strengthening some of the type signatures. And that's our only command batch. There's a few odd command nones. So either we need to do something very, very similar to command batch, which would look something like that. So it's not hard. You could maybe, if you had a function that built stuff up, you could try to ignore command nones. This .map perform effects. It's that. I don't think we're actually going to generate so many. It's a really big deal. But you could do a filter for no effect before the perform here. You'd still store all the command nones unless you had a little function that just bailed if anything was filtered up front. Of course, it's not doing anything. This is... oh. So that was a unknown type. This is going to be a known type because we're going to have to get this in place, we're going to have to do that. Oh, yes. This is not just the function. Okay. So that lets us go down in here. Okay. Now, can I do this, or do I have to, like, do a checkpoint? Cannot find a lambda.response. Response. HTTP request call produce command message. Oh, yeah, we have to replace all. Okay, so this is in fact going to be a big step. And I sort of like over sketched this. For what we're doing now. Ooh. Command map. I think we've actually removed you. Yeah, this might be able to say that if the internal effects were themselves a batch, no, actually this isn't it. We need to command batch the result of that. So yeah, you could try to keep it as a flat list. So if any of the subcommands is a batch, then we handle that, actually, instead of just performing it, we handle it specially. Or we flatten the list. But that's optimization. I could try to get all of the things that produced what will become effects into a set of functions. You just go through and replace those functions. Okay. So any of those lambda dot functions, like that. Okay, so that didn't turn out so great. Didn't remove the old one. Command.batch. Yep, command.batch. I think there was a command.none. Initial model fine. With all requests. Okay. Other thing, I think we don't need you anymore. Yep. On lambda.event, we translate it into a message. And handle is just because we have to put something here. The Lambda update is not quite update event. Although it could certainly handle the translations. Effect type. So update event has been semi-app specific. Application decrypted. I mean, that's where my let env stuff came from. So that's processing the result, which had the nice effect that you could just kind of streamline that in there. Well, it is still handling the OK case. It's the OK. Yeah, we're back to the code we had. It's just all back up in the main loop. The only thing you're really doing is HTTP response mapping. And it's not even an env, it's a list. Well, what we can do is we can go back to this. Doesn't condense all into air again. Now I guess I could have yet another update layer that like we have like decrypt from Lambda and then we produce yet another layer of events. Because actually, if we were doing these things, it'd be like that. Well, maybe that's one level and it's okay. Yeah, so you could have their, well, if you do the pre-layer, you either need a different message type or you have to just do a blanket ignore in the next level, so that's not so great. The update event. Ah. Result string list A. Oh, right. We were counting on this being translated. And actually, this is now more like what we're doing elsewhere. Of course, we're not actually testing the decrypted part of this right now. It can only be done on Amazon. So I still need a translation layer. From Lambda events to my events. Except for HTTP responses, which can actually generate my events. So that's what the subscriptions do. They say, okay, if we get this event, and you send that message. And that does the sort of inversion of control versus receiving the Lambda events directly. Fortunately, generalizing this has pushed a lot of the stuff that we were kind of handling at the barrier level down into the individual app level. I guess there's something like this, you know, it's like my message. But it doesn't work with it. Well, you'd have to have 2 levels of HTTP, of Lambda events. You essentially have to have the version that included only these. If you're going to do events that we translate into our events, because the HTTP responses will specify how to call them back. You know, or you do a subscriptions type thing. I guess, okay, decrypted is supposed to be kind of a request response thing. You'd have to put well, it's a case-by-case request response thing, so you'd need something like the HTTP ID. System. All right, so we moved the decrypt out. If we had something like a subscriptions, we could do some degree of processing before putting it into a message. Something like that problem, you can't just throw it away if it's an error. To actually move this up, it would need different data models. So Lambda model will have pending requests, and it would have to contain the app model. All right, so we have to start thinking about how we do this. This gives us no safety whatsoever. I guess that and it would be, There's two different initial models. Maybe we need to start separating some codes so we have a better idea of what is where. So this subscription would actually have to be in Lambda side. And I guess mainly the event processing. You would have to define the effect type. The app would have to import it. So we'd have to define a module in order to get a namespace on it. Lambda update is for you. Update event is kind of for you. Well, that's doing a model effect right now. I think that might not be what we want. So maybe the perform has to start moving into here. Update event is only mentioned here. However, you are directly referring to update, so that's across the line. You refer to decode response. My error is a little bit of a hairy one. All right, so at that level, we have more errors. Decode response. code tagger came from the expect. I guess expect JSON HTTP match. Would kind of be down here. This would have to get published. Outstanding requests is all we deal with there. Expect model HTTP error. So we might have to sort of like low level and high level HTTP error. Because unknown response. Oh. So we never even switch off of this. Interesting. What does HTTP match do then? Oh, what's a debug to do? It says it returns an expect message. So that would have to be like expect of unknown response. How would that work? What do we do with an expect? We call decode response with it, which is expect string, so that would have to be, the expectation would have to be like unknown response. And like that would reply with the unknown error type? Because this means the expected JSON is actually doing the bad body additional decoding here. Init we're going to have to look at. My error is closely related to that error type. HTTP response, I think, is a little bit more application level. Yeah. State for event is in our update. Step append state with our requests. Execute request is in step. Remember, HTTP request might be something that goes in the effect type, essentially. The perform current doesn't take a model. May need to. State request is related to execute request. I also use you here. So maybe that makes the effects branch a little bit. Okay, so next request ID would also be part of that. To Lambda request is essentially our Well, it's an effect here. If it's handled there, then that wouldn't be the effect. It would be HTTP of our effect type complete with the expect. And that would translate that to Lambda command plus the model state update. So maybe we need to kind of do that while we're still on single model. So fetch, decode. So for that to work, Lambda's going to have to publish that HTTP request type. So it's going to have like its internal type and its external type. Or we actually just do make them the same and ignore the expect at the command level. Which would essentially be when translating it to throw it over the wall. Maybe at some point I'd want to do some more like upfront URL processing and things. So you just have to come up with names for two different types of HTTP requests. All right, so remember HTTP request ultimately needs to be down here. It's kind of the dual of HTTP match. That is currently doing the to Lambda request. Oh, I had an HTTP request, which is what I used in all these things. So got all that, and this is the stuff that feels like it should be in our application code. Let's talk in headers a little bit. Once that actually is moved over, we could potentially have the exposed functions generate the effects and have the perform directly. Well, you'd still have like encoder functions and things. Execute does the state request translation. So a next step would be to have this happen while we're doing the effects translation. Now you're currently producing an effect, so that would probably be like we got an effect, we had an HTTP request in it, and this HTTP request is with expect. Something that calls to Lambda request. To Lambda request would, instead of being HTTP, be the actual Lambda call. So that would start to produce command. Means that would start to produce command. So is that just remember HTTP request? And what does this look like without that? State request is HTTP request. So HTTP request is that type alias, which isn't really tagged with anything. So it would not be identity, that would be a wrapper that puts it into an effect. And the twist is that our perform function has to do further work on the model stuff. So you would essentially make that itself a kind of update. So the update event is going to give us the tuple. Which makes all this much messier. Because one of these things needs to deal with the update. Oh, that makes this very messy. Wait, the effect is response? Yeah. So this is the one that needs matching. Or no, remembering. Response is, okay, we're sending a response to our witchajiggy, to our Lambda function. This gets super messy. Because if it can perform state updates, it effectively turns into a kind of fold, but we have to be doing all the appropriate updates every time. Does that mean that we would actually be better off making perform function like a fold function? Well, we have to remember, we have to both update our model, so they can't treat that as the state. And possibly build up all of our commands. So that gets the effect and the state and produces the new state. Well, there was only one effect in here when we came in. And it's not even this model, it's the model that comes out of this. So it's a list.fold. Something that's not just perform. Over an initial state. That's the output type. And then you're going to take each effect in turn. The sad thing is that well, that's the state that has to be in the output format. Perform the effect, the model, and the command. Perform on model, effect, and we have to do a batch at every single layer of this. If you update them all individually and they all make model updates, then that's not super valid. You could probably come up with a iteration that separately kept the list of commands and batched them all at once, but while still threading the model. It could just get a lot hairier. And that's going to result in a model command but only the first one is guaranteed to be null, so we have to deal with that. This is not as easy as I was hoping. That works. We're not actually doing multiple commands at once. We may never actually do that. Nope, that didn't save. Right. Oops, missed a character. Okay, that fixed just that. So the model is available. And then we needed to do, let's see, that's HTTP request model. Does that fit into here as is? Now this type would change to produce that directly. Remember HTTP request. That type will change. You're a model, you're but we have to put the we have no incoming commands because you're just by yourself. Yes, you're still a little bit of a one-liner as is. So you become that. That was what we were going to pass through to lambda.http request. I don't know that you have a message type either. Okay. Then you don't do that. These, I don't think we have the remember step at all. Which means that these could go back to just being straight up commands. Or effects, anyway. State request is just, oh, you're an HTTP request, not an effect. Fetch token. Right, so it was remember that was applying the HTTP to it? I've already removed that code. So the effect is going to be this one, though. And then remember is going to call to Lambda request. So in Elm style, these would in fact be effects. It was kind of cool that they returned request structures. Auth state. Execute request to specifically doing state requests. That's not really a thing you would use. Lowercase HTTP request. Okay, so that's fetch token. You're in effect. Execute request. State request needs to be updated because all of its functions do that. Those things all return HTTP effects. Get recorded there. That'll translate. Oops. Types. It makes multi-stepped requests. So we've got update event, which is doing this. Update event is still a model effect. I guess that makes sense. So then you take anything that resulted from that and map it into commands and execute the commands, which is what Lambda update's doing. This would be a command if every point we called update did the perform mapping. All right, so now it's getting really late. Encapsulate HTTP responses. Did I do that already? A little bit. We sort of have effect type. What is the HTTP matches there? Landing program. HTTP requests types are kind of both Lambda. So that's awkward. Might fix HTTP effect name. And then a lot of the complexity that used to kind of be in the update events layer has kind of crept back into the main program layer. as we've tried to make that section more and more general. There's no longer a layer that's like, okay, well, we got some still kind of messy Lambda stuff. Can we wash out all the errors and things? But that sort of means we'd need another message layer to, like, okay, what are we going to get directly from Lambda? And then what are we going to do with that? That could be sort of in the handler functions instead of just being a tagger. And you have things like this, where it's just an error. I guess maybe you could do the translation to just report an error. And you can go back to got user by name. Oh, and then there's the whole next state thing here, which that could be in the message, I guess. Yeah, and there's error response with all requests. Because you're not really going to fetch anything I know an event. We've got like global fatal error and locally fatal error. Maybe there should be submodules of Lambda, so you could have like Lambda effect. Lambda HTTP that has the public part, and then the private part is just in the main Lambda module. Maybe like enter HTTP or request HTTP, or that's just the HTTP request message. Huh. Anyway, it's lunchtime. Thanks to subscribers. Thanks to everybody who hosted me. I'm gonna go eat lunch. Normally I'd be back on this Friday morning. Maybe I'm a bit overloaded with Satisfactory. I should do some of this sometime too, but I still have to do like grocery shopping and everything, so we'll see. This is when I'm normally on. And have a good day.